Hello everyone and welcome to another Tri-C Anthropology video tutorial. Today we're going to be talking about spreadsheets and how we use them in social sciences. So we're going to be discussing a few key concepts including levels of measurement. We're going to be talking about a few basic descriptive statistics, and we'll also be talking about a few functions within these programs, specifically Google Sheets, but then also in Microsoft Excel. They're mostly the same between the two, but there's a few minor differences that we might get into when talking about these two spreadsheet applications and how we might organize these data for specific purposes within the social sciences. Now, I've got an example here that I pulled up that will be available to students who are on my courses in Blackboard, either via Excel or a Google Drive link. And basically this is all mock data from a fake archaeological site that we'll be using as our mock example of how to organize data in a spreadsheet. So before we enter any of this mock data in, the first thing that we want to understand is what kinds of data we're going to be entering into our spreadsheet and what the parameters of those data are in essence. And in order to understand that, I'm going to switch between these two sheets for this purpose right here. So I've got the raw data, and then I've got the codes. Now the codes is important because this is where we're defining what these variables can take on in terms of criteria and parameters. So you'll notice the first row I have here basically is describing each of the 4 levels of measurement for these variable types. Now if you're not familiar with the 4 levels of measurement, they're basically nominal, ordinal, interval, and ratio. And so each of them encapsulates different levels of measurement. So a nominal variable has no meaningful distinction between the different categories. So in our example that we have here, we have a couple nominal variables here. So artifact class. So there's no meaningful distinction in terms of distance between glass and ceramic. They're just categories that encompass a certain object, but there's no meaningful measurement actually happening there. I can't say, glass is 5 units away from ceramic. It's just nonsense because they're categories. They don't have a means of measuring, right? So that would be a nominal variable. Oftentimes you'll see nominal variables in qualitative analysis and qualitative data, right? Because these are qualitative. There's a quality about them that can't necessarily be measured in the same traditional way that we think of with, say, a ruler, right? And I guess you can't really tell that this is a ruler because it's just a bunch of stamps, but my fun little stamp ruler there. And so the next level up is ordinal scale. So ordinal scale has a specific order, but there's no meaningful distance measurement happening between those orders. So for example, rating a movie on a scale of 1 to 10, while in our minds we think that there is a distance between 1 and 2 on that scale, someone's 2 is not the same as another person's 1. So there's no standardization in that scale. While there is an order, it doesn't necessarily mean that there is a fixed, defined, and known distance between those scales. Or someone else's pain tolerance, for example. A 5 on the pain scale for me is probably going to be different than a 5 for most other people on a pain scale of 1 to 10, right? So there's an order to that pain scale, but it's not necessarily a defined distance between them. And for our purposes in this raw data example, we don't really have any examples of ordinal scale, but if you're doing other social science studies that might include, rating things on a scale, 1 to 10, how you feel about a certain thing, if you've ever taken peer evaluations or teacher evaluations at the end of a semester, and they ask you from 1 being least satisfactory to 5 being most satisfactory, that would be an ordinal scale variable that you might include in your spreadsheet, right? And we'd probably want to put a sheet in our spreadsheet down here indicating what our variable types are and what our levels of measurement are, right? So if I wanted to add another sheet, and how I did this down here is basically I clicked the plus button here and then created a new sheet, and now I can right click on this and I can rename it, and I can do the same thing in Google Sheets. There's a plus button here, add a sheet, then if I right click, I can rename. So the same concept works for both of them. And you'll probably want to do this with any spreadsheet you're working in, whether you're in social sciences or not, so that you know what your data mean. Because people forget. I know myself, I'm guilty of this, coming years later or even months later back to the same spreadsheet. You might forget, well, what was that variable again? What kind of a variable was it? And what were the possible categories of this nominal variable? Or if I use codes, so oftentimes people will enter codes for their data. So instead of saying glass, ceramic, lithic, I could say 1, 2, 3. And obviously, if you don't have your code sheet in here like we do here, and you don't say 1 equals glass, 2 equals ceramic, and 3 equals lithic, then it's going to be very easy to forget what these data mean, and it's just going to be a bunch of numbers in a spreadsheet. So it's really important to have that code sheet there, just as a quick reference for you. And then the last two levels of measurement that you really need to know are interval and ratio scale. They're very similar to one another. The main difference between the two is a defined 0 point. Technically, when we're talking about temperature in Fahrenheit and Celsius, those are technically interval scale and not ratio scale, because technically 0 degrees Fahrenheit is not actually 0 degrees, whereas if we were talking about Kelvin, which actually is 0 Kelvin would be the absence of all heat, then Kelvin is technically a ratio scale. And so it's a fine distinction, but we're not really probably going to be running into a concern about the differences between the two for the most part in our data sets that we're working with in social sciences. But it's important to keep those in mind. So you'll notice here that most of our columns here are ratio scale variables, and I just put in some general ones here. And you'll notice this last one here, general description, which is often found in catalogs for artifacts and whatnot. This one is not really a scale of measurement. It can't really be categorical because it's going to encompass all sorts of unique entered input, right? So if I typed in, projectile point, unless I repeat this over and over and over again in my spreadsheet, this could eventually become a category called projectile point that I'd have to go out and define, which if we wanted to talk about classification and systematics, that's a whole nother lesson in itself. But for our purposes right here, this general description doesn't really fit a measurement scale. Since we're mostly dealing with 3D models for a lot of the stuff we do in our anthropology classes, and we don't necessarily have access to them physically if we're taking a class online, volume is something we can measure through 3D models and something like MeshLab if you've watched any of my other videos on how to use MeshLab. And some of these other linear measurements are pretty straightforward to capture from a 3D model as well. So in this one, we've got a lot of data encompassed in one cell. Test unit 5, level 2, 10 to 20 centimeters below surface, the example site. We could break this out into multiple different columns of information, right? So we can do that in Google Sheets by inserting left, inserting right. We're going to insert left. We could say site. So now we have a nominal variable here. If we wanted to go to the code sheet, we'd want to remember to add that in. Insert left site. This is nominal. We call it site. And then if we have a list of sites that these are from or different contexts, we'd probably want to list them out here. So the only one we have is the example site, assuming we can spell. But then if we scroll over a little bit further, we might notice there's this variable right here. Now, it's hard to see this variable, so one of the tips that I'd recommend doing if you can't see it very well is when you hover over in between two columns, you'll see this can expand out if I double click it, and it'll go to the full length of the longest segment of text or numbers in your column. And the same thing's true of Excel. If I bounce back here and I double click this, so I can click and hold, I can left click and hold to stretch it out. And if I double click again, it's going to stretch it back down to the size that we want of the text. But you'll notice it says length divided by thickness. So you can do formulas in Excel and Google Sheets to transform variables. So maximum length and maximum thickness might not be super useful on their own, but if we want to start to look at patterns in these data sets, we might want to start to transform variables, maybe dividing one by the other. So we don't need to get into the specific research behind why length divided by thickness is a useful measure, but suffice to say, for lithic analysis, it's a common abstraction from raw data. And the way we did that in Excel is we can see this little area up here is going to show me what formulas are being used. So we're not really going to dive deep into all of the different formulas you can use in Excel. There's umpty gazillion of them. So we're just going to focus on using some really basic math in Excel and Google Sheets. So you always want to use the equals sign, and then a few of the basic symbols that you'll be using. So if we wanted to do division, we could literally click on the cells that we want to divide. So I want to take this maximum length, and then I do the backslash to equal divide by the thickness. And then when I click enter, it does the multiplication, or sorry, not the multiplication, the division for me. And then if I want to repeat that process, I could manually enter it in over and over again. Or I could go down to the bottom right here, and when my white cross turns into a black cross, I can drag it down, and then bada bing, bada boom. It doesn't really, here, I'll delete all these so you can really see it in process. When I drag it down, it auto-populates with those math equations completed for me. And the same's true of Google Sheets as well. So if I wanted to do the same thing, you can see here's the formula location again, and then when I highlight it, it actually shows me what's being divided by what. So it'll take me to L5 divided by K5, and that's what's actually happening here. Now I could also do multiplication if I wanted to, so I could do, I'm not sure I'd want to do that in this case, but I could. So the asterisk is going to do multiplication for you, and now they've been multiplied. Let's undo that. Other ones we can do, obviously, subtraction, addition. The symbols are going to be familiar to us. If we do this again, plus. So, right, so basic mathematics that we can do, basic arithmetic, I should say. But we can do a few more descriptive statistics that are built into these spreadsheet applications that I'd highly recommend. Anyone who's dealing with spreadsheets are probably going to be dealing with mean, median, and mode. Obviously, the average, we could do the equation manually by hand. We could add up each cell. So if we wanted to do the average weight, we could take this weight plus this weight plus this weight plus this weight. That's very cumbersome, right? So it's not very efficient. And then obviously we could divide by the total number in each case. But if I click on the equals sign, you'll see it's already prompting me with selected suggestions, because these are two that are commonly used functions within spreadsheet applications. Whether you're using Google Sheets or Excel, the functions are going to be the same in both of them. So I could break down sum of all of these components and then do division by the total number. Or you'll also notice here that I already have average as an option. So I could click on average, and then it's going to auto-populate with the text needed to run that function. So you can see average is equals average, and then in the brackets, I'm actually putting the range of numbers I want to average. So if I were to do this, type it out, I'd type in average, and then I'd select. Now, one of the things you can do in both Google Sheets and in Microsoft Excel is if you hold Shift and you use any of the arrow keys, you can navigate around. So I'm holding Shift and pressing the down arrow to highlight all of the cells that I want to average. Double left click on it, it'll show me what I've averaged. So I didn't average the thickness of the ceramics and the lithics. I separated them out because there's not really much utility in combining the thicknesses of two different material types, right? Analytically, it's probably not going to tell me a whole lot, but it might tell me something about the average thickness of my stone tools, right? You'll also notice I did the same for weight, and I did the same for max length. You might want to use your nominal variables to set parameters for what you're going to be looking at with your ratio and interval scale variables. So, like I said before, I wasn't looking at ceramics and lithics together. I wanted to just look at lithics or just ceramics. And you'll probably be doing the same in your own research. You want to look at things by meaningful categories. So I can also visually represent a lot of this data. So this is all just a table-based and using the spreadsheet applications. We've talked about functions, right? Using that equal sign to calculate basic arithmetic and using average. But how do we visualize it in different ways using charts? So if we're in Google Sheets, and let's say I wanted to visualize weight over thickness, or actually let's do length over thickness, right? Because that's basically what we're capturing here with this transformed variable length divided by thickness, right? If I want to visualize that so that I'm not just looking at these numbers, I can select these. So remember Shift and then using the arrow keys to navigate around. What I can do is I can go to Insert and then I go to Chart, and it's going to instantly do a column chart or a bar graph, but we want to change that to a scatter plot. Now a scatter plot is really useful for visualizing ratio and interval scale data because it's taking a ratio on the x-axis, ratio on the x-axis and a ratio on the y-axis, and plots them as dots, basically, where the two meet up in a coordinate system. Whereas bar graphs are pretty useful for nominal variable, right? So they give me quantities or frequencies of specific categories of things. So a bar graph is probably not going to be great for trying to visualize interval or ratio scale variables. And when I'm looking at a scatter plot, I'm looking at linearity. So I'm looking for a line pattern, either going from the bottom left to the top left to the bottom right, or a straight line across. Those are telling me different things about the relationship and patterns of these two variables, right? So you'll notice in this scatter plot, it's kind of all over the place because I don't actually have one dot representing both variables in a coordinate system. So that's going to be a problem. So what I need to do in this situation is I actually need to go back to the chopping block. So I need to tell Google Sheets or Microsoft Excel what I'm going to be organizing these two variables by, what I'm going to be calling them. And so I actually really need to encompass some sort of label for these two variables. So this specific Raditz projectile point has these two variables. This Adina projectile point has these two variables. Now that I have some sort of label for each of the pinpoints, when I go to create that graph or that scatter plot, it'll actually plot them as one single dot. But let's do the example here in Microsoft Excel as well. And Microsoft Excel will give you a little prompt down here. So in Microsoft Excel, I also want to go to Insert, and then I can go to Charts. So it's a little bit of a different setup. And I can see the scatter plot option right here. So I don't have to use the drop-down menu like I do in Google Sheets. And so I can just immediately select a scatter plot. Another way we can do that is when you hover over this selected data set that I've got here, you'll notice this little box down here for quick analysis. I can go to Charts, and then I can go to More, and then I can go to All Charts and hunt down Scatter, XY Scatter. And you can see right away that we have a clear linear pattern here. We can see that as the x value increases, so does the y value. And so there's clearly a pattern that when one increases, so does the other. So if length is increasing, so does thickness, and vice versa. That's telling us there is a strong correlation between length and thickness. They're going to vary together, co-vary together. Now if we saw this pattern going the opposite direction, where we flipped it so that there is a line going from the top left to the bottom right, or if you can visualize a line here, then we would say that as length increases, thickness decreases, or vice versa. We'd have to know what these variable axes are labeled as. And again, if you want to label the axis titles, you can do that here. If you want to visualize what the data are, you can also hover over them and see the individual pinpoints. So in this case, this dot represents 7.3 and 69.2. In this case, we can figure out pretty quickly that the x-axis is thickness and the y-axis is length, just based on the differences in number quantities. So that's one way we can visualize our data. For organizational purposes, I don't recommend trying to do too much in one sheet because then it gets a little confusing. But for simplicity and expediency, I'm going to do it right here. So we're going to just say Upper Mercer, or actually let's just keep it even simpler than that, lithics and ceramics. So we know that we have lithics and ceramics in our mock data set, right? So I'm going to go in here and I'm going to select all three of these, and you can't see that down here, but if I move it, you can see it says count 3. Now this is going to show up the same in Microsoft Excel if I did the same thing, and I went over here and I did shift down down. It's going to show up again, count equals 3. And what's also fun is if you have, in Excel at least, if you do this same function, or rather just highlighting numbers, so let's just go over to weight. If I do shift down, 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 you can see down at the bottom that's actually going to spit out the average, the count, and the sum. So it's already going to auto-generate those basic descriptive statistics just by highlighting those cells. So sometimes you don't even need the function, at least in Excel, to calculate these basic descriptive statistics. But remember, we're trying to do a bar graph. of nominal variables, right? So let's go back to our Google Sheet here. We've got 3 ceramics, and we've got, let's do a quick count here. How many is it? 5 lithics. They're so small you could probably just count them by hand. Now we want to highlight our whole data set, insert, chart, and see it's already set to scatter because that's the last one I selected. But I want to do a column, right? So here's a bar chart telling me how many lithics I have. So that's a simple bar chart that I could do of nominal variables. But again, your visualization is highly dependent on the types of variables that you're using and the measurement scales or levels of measurement that you're using. And so obviously a nominal measurement is going to be better displayed as a bar graph, whereas 2 ratio or interval scale variables are going to be better displayed in something like a scatter plot. So we've learned about basic descriptive statistics. We've learned about how to run basic arithmetic functions within Excel. We've learned a few things about how to navigate within Excel and Google Sheets, and how to display our variables, and how to set up our spreadsheets. So hopefully that gives you enough tools to be dangerous in spreadsheet applications. And we also talked about, again, our levels of measurement. And I'll put a link in the description about this specific article that has this specific image in it. And I'll also link to the Tri-C Foundation. If you enjoyed content like this or other content by anthropologists like myself, then I encourage you to donate to the Tri-C Foundation to support more anthropological content like this. And with that being said, until next time, never stop learning.